In this series of videos, I'm going to take you through adding a feature to a HTML5 JavaScript web app, which has all of the components illustrated in this diagram implemented to give you continuous feedback in your development process. And I hope that as you watch me add the feature and use all the tools that are described here, that you'll see how used together these can help to make your HTML5 JavaScript web app development experience both productive and fun. So let me give you some context. The application I'm going to be working with is one of the TodoMVC sample applications, and specifically the one written in AngularJS. So let me just give you an idea of what that application looks like. Let me just get it up on my local dev server. So that is this portion over here, the local HTTP dev server. Alright, so here's the application. It's a very simple single page HTML5 JavaScript application that implements a to-do list. So for example, I need to record the steps in the tour. I need to upload them to YouTube, and I need to write about and then as you do each of the steps, you can check them off. And the feature that I want to show you adding is over here. You can see that it tells me how many items I have left, but it doesn't tell me how many I have done. And what I would like it to do is tell me you've done this many and then you have this many left. So that's what this series of videos is going to be about. And in the process, I'll be illustrating each of the components shown in this diagram and how they all hang together to make your development experience fun and productive due to the continuous feedback that you get. So the first thing to do is to get a copy of the source code from the central source code repository, which in my case is GitHub, onto my local machine so I can open it with my text editor. So I've done that using my GitHub client, and I've cloned the central repository, and now I can open up the files in my text editor, and here I have the app files, here I have the test files. And as I mentioned, I can start up a local development server. That's this one over here, HTTP server, and that allows me to browse a local copy of the application completely separate from everyone else. So if I break things, it doesn't affect anyone else working on the team. The first thing for me to do is to make sure that all of the tests pass. So this step over here is that we have a local test runner and a set of tests that verify that the functionality that I pulled down from the source control works. So it's important for me to know before I start that I'm not working on a broken code base, I'm working on a code base and everything works. So to run the tests, I simply run the yeoman test command, and here you can see it runs through some things and it tells me that it executed 14 out of 14 tests successfully. Great, so I know that no one else has broken the source code, and I can start adding my new feature knowing that I'm working on solid foundations. So the first thing for me to do is to add a failing test, and rather than have you watch me type, I'll just pull out one that I created earlier and run the test to demonstrate that it fails. Right, here we go. So before where I had 14 successful, I've now got 15 tests, of which one failed, and it's the to-do controller should calculate to-dos correctly. So let me go and just show you where that code is. So here under my tests, under my spec tests, under controllers, to-do controller, I have a test called having some to-do should calculate to-dos correctly. Should calculate down to-dos. There we go. So what I'm doing is I am populating my internal models with some to-dos, and then I'm checking that the done count has been set to 2, which it says it should be 2, but it's undefined. Great, so now I know that if something ever goes wrong with my with my done count that the person who gets the failing test is going to have a useful error message. Right, so now that I have a failing test, it's time to write the code to make the test pass. So this is the location where I need to define the done count model object. So here I got done count. So the done count is the total number of to-dos plus the remaining count. So let me run my test to see that they pass. Oh. So why would this be the case? So it looks like my test is still failing because it thinks that I've got 8 that have been done, but there are only 2. Right, so this is the kind of place where having unit tests really helps, because it picks up a really stupid logic error that is so easy to make. In this case, I've inverted the addition. So actually the number of items that are done are the total less the ones that are remaining, not plus the ones that are remaining. Let's see if that logic is correct. Excellent. So hopefully that can show you 2 things. One, how writing your tests can help you avoid stupid errors that would take an age to pin down with a manual debugger. And secondly, I now know that my new feature hasn't broken any of the existing features, because all of the existing 14 tests still pass. So that's great. I'm on to the next stage. Right, stage number 3. Now that I have my calculation handled and the unit tests run my calculation, I need to display the value on the UI somewhere so that the user can actually see how many items are still remaining, or rather how many items have been done. So I want to put the number of items that are done over here in the footer. So to do that, I need to add a new piece of HTML which binds to the done count property which we created over here. And here's another thing that I just want to show you. We talk about this watcher, and the watcher watches for changes in the source code and then automatically updates things like the browser. So observe over here, nothing's happened there. Put some new HTML in, I hit save, back to here, and see my page has been refreshed without me actually having to do any refreshing. And that's because of this watcher that just helps to give me continuous feedback and speed up the process. So anyway, here we have my piece of UI where I'm displaying the done count to the user. So I can see, great, done 1, I've got 2 items left. So if I check the other one, there we go, now it says 2 done and 1 left. Excellent, that is that step completed. Right, so the next step is to ensure addition works in all the browsers. So essentially I want someone to add some steps and go through the process of clicking the buttons and checking that this location gets updated. And I'm lazy, I don't want to manually having to do that in all of the multiple browsers, so let's use Angular's end-to-end tests to help me with that. So what we've got is a set of end-to-end tests which are written over here in the test folder under end-to-end, which essentially does things like opens up a browser, navigates to the index, and then puts something into the new to-do box, clicks the add element, and then checks to see whether various elements in the UI have been updated. We can watch that test in action by starting up the Yeoman server. Right, test mode. Here I have my test runner, and what you can see is that it's going to run through all of those tests, and here it is manually clicking on all of those steps. And in fact, if I go and have a look at the test that I've just added, you'll see that I have a test which checks to see that the done count is incremented. And if I stick a pause statement in here so I can show you how it works, right, you'll see that what's happened is my test had automated the process of adding something, clicking on the button, and it's about to go and check to see that that says 1 done. And I've just put the pause statement in here. When I resume, it'll continue. Check the done count. Yes, it equals 1. Great, test passes. Now I know that I have a way of testing that all of my UI displays as it should. And now comes the really clever part, because I have an automated way to run that in my single browser. So since I can do it in one browser, I can do it in multiple browsers. So what I have here in my end-to-end test configuration is I say I would like you to test in Chrome, and I would like you to test in Safari, and I would like you to test in Firefox. There we go. So now when I run Neoman test end-to-end, you'll watch that it will fire up each of these browsers in Chrome, Safari and Firefox and run the same set of tests in each one dramatically faster and easier than a lazy developer like me would ever do. I can save myself a lot of manual hassle by simply writing a set of tests to manipulate the UI and then having my test runner run it across a collection of browsers, so I can quickly make sure that my UI is going to function correctly in all of the major browsers. And that's a great time saver. Right, so I have added my new feature, and I have a set of tests to prove that my feature works and to ensure that it works across all browsers and that it won't get accidentally broken in the future. Now the next step is to make sure that it works not only on my machine but on the gold standard machine, which is our build server. So the next step is for me to take the code from my machine and push it back up to the central server. And what that's going to do is going to kick off a build process, which is essentially what I've been doing locally, but just on a pristine, clean environment, and run through the steps of compiling the site and running the test and then reporting back on some metrics. So let me show you how that works. So really all I have to do is push my changes out to happen repository, go and have a look on the build server, and you'll see that it will trigger off automatically a new build. Here we go. So it's noticed that there are new files pushed from me, and it's running through the same build process that you'll remember seeing me run locally. Running through, getting to the point where it's running all the tests. Great, and the tests 15 out of 15 have passed successfully. And if I go back to the project, I can see here that I'm getting some metrics showing me how the number of tests have increased. There we go, I got one extra test, so that's gone up. I've got some information about code coverage, so that's how many of my lines of code are actually exercised by my test. So that looks like it's pretty consistent. I can go and have a look at the particular details. Here we go. I can see that my services scripts are covered pretty well, but over here perhaps the directives need a couple more tests, and I can drill down to find out exactly. There we go. I can see that I don't have any tests to check to see that the element gets focus. Right, so that's showing how I can now be confident that I managed to copy all the files off my machine back into the source code repository. I know that I haven't left anything behind because it ran on our gold standard build server, and it ran across all the tests, proving that the code still works. So I know that I haven't broken anything, and more importantly my teammates know that I haven't broken anything. If I had made an error, the build server would have alerted everybody, sent me an email, and I need to get my act together to make sure that the code in the source code repository was of pristine quality, so that the next person coming along could start working on a solid foundation. So the final step in our continuous feedback is that once we've pushed code to the central repository, it's been built and the tests have run successfully on the build server, we want this to automatically trigger the deployment process to the QA site, so that people other than the developers can have a look at it and give us feedback quicker. So let's see how that works. So the first thing is that we don't want to deploy broken builds. So if we push something to the source code repository which fails the tests, we want the process to stop there. So let's have a look to see how that would work in action. So here we have a deployed version of the site, and most importantly, notice that down in the footer here it says that it's version 25 of the site. And now we go and we have a test which is going to fail. So here this test says expect 1 to be 2, which is clearly going to fail. So I'm going to push that up. Spell that correctly. Okay. Now we want to watch our build server. Here we go. Here's our build. Want to watch that's happen, and what's important is that if it fails, we don't want the deployment portion to kick off. So here we go. The build has failed with our failed test. Yep, one failure in the test. There's our fail should not deploy on test failure, which is what we wanted. And if we go back and check our live site, yep, it's still on version 25. So the deployment of the broken code base didn't happen, which is what we wanted. Now let's go back and make it remove that failed test. Now this time what we want to see is that our build pipeline works. So here I'm looking at our build pipeline. Here we go, our build is running. What we want is that if this goes green, then we want to see the deployment process kick off. Excellent, that's gone green. Our deployment process is kicking off. It's automatically taken the code that was built here and deploying it onto our server. Great. So here we have 8 plus 17, so 25 seconds after we committed our change, our site has been updated. And there we go, we can see it's now version 27. Remember version 26, which was the failed build, never got deployed. So there we go. So that's the entire process. We've seen how we grabbed the source code, we used our watcher tools, our local dev server to do manual inspection. We saw how we can write unit tests and run them in the test runner, how we can write end-to-end tests and then run them across multiple browsers to save us effort. Then how we push that back to our central source code, and then we make sure that we can still build and run the tests on our gold server, our continuous integration server, which builds the code, compiles and minifies, runs all the tests, runs across even more browsers, and we ran locally, check that it all works, calculates metrics, and if it all goes well, increments the version number and deploys that to the QA site. So you can see how through this whole process we've optimized to get feedback on errors as close to the point where we actually type in our editor as possible, because that's the quickest time that we can fix them.